Hey, and welcome to the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. Here, we dive into the cutting-edge worlds of prototyping, aerospace, rapid manufacturing, high-velocity mass customization, and beyond. I'm your host, Jordan Rose. Today, we welcome Tom Mudd, Head of Technical at digiLED, one of the world's leading makers of enormous high-definition LED screens. Tom's journey spans from backstage at major music tours to tackling massive AV installations at stadiums and global venues. He brings to the table a rare blend of hands-on technical know-how and creative solution building, especially when it comes to reducing power consumption in traditionally wasteful displays. Tom, welcome into the show. Super excited to have you on. I know that digiLED does a lot of exciting projects, specializes in different screens, custom screens, large scale, green, energy efficient. I just wanted to start before we get into digiLED and what you guys do there. I wanted to learn a little bit more about yourself and maybe your professional journey and how you've come to become the technical lead at digiLED.
Well, thanks for having me, Jordan. Yes, my journey through the world of LED. Look, I was studying electronics at university in the mid-90s, and all of a sudden, mid-1990s, this miraculous thing got released called a blue LED. Prior to that, we had red, we had green, but a gentleman over in Japan finally brought the blue LED to commercial reality. And I remember at the time, bear in mind these things were like $50 per LED, but I remember going to my lecturer and saying, hey, we've got red, we've got green, now we've got blue, you could make a TV out of this. And he turned around to me and he said, Tom, if you can find anyone mad enough to solder a few thousand LEDs together to make a screen, you go for it, my son. So sadly, that was the point at which I failed to become the inventor of the LED screen. But after graduating in 1997, I started off with an innovative little British company who did indeed build the world's first colour LED video screens. Yeah. Spent the time up to the millennium working with those guys as a trainee screen technician, very much involved in taking the technology out to the live events world, doing festivals, concerts. You know, sometimes the screens were on stage, sometimes we'd be doing drive-in movies. But the technology really was in its infancy then. You know, the screen we were touring with had 320 by 240 pixels to it.
Oh, wow.
And I think you've got more than that these days on a watch.
Yeah.
Yeah. That took me up to the millennium. Then I kind of reached out and got a little bit international then. I popped off to the Sydney Olympics. Do you remember those back in millennium time?
Barely.
I'm showing my age here. So Panasonic are the international provider of all AV technology for the Olympics. And they put together a collective of what we called Eurotechs and flew us out to Sydney. So yeah, my first big taste on the world stage of screens was Sydney Olympics. And I kind of got the travel bug then and realised that there's a whole wide world of people all wanting giant LED screens. And here I am now 25 years on from that, and I'm in the lucky position where people have paid me to travel the world to do big screens for them. Along the way, though, a gentleman called Graham Burgess, who founded digiLED, he captured me and he said, Tom, come and do all of this stuff for me. So 2008, I put on my digiLED hat, and I've been working with the Digi team ever since.
Wow. Okay. So you were very much in at the ground level then with the technology, and you've kind of watched it expand through the years. I know that digiLED both has permanent installations as well as, more event-based, which was your early exposure and kind of what drew you to the profession. Can you talk to me about what digi-led does that kind of separates you in the industry? Like what makes you guys special?
Yeah, I mean, you're quite right. Early on, digiLED were pioneers in rental LED.
Mm-mm.
If, for example, you've been to a Bruce Springsteen concert, you will have been looking at digiLED rental screens.
Wow. I
Um,
actually have been.
there you go. Right. Yeah, but Bruce has been touring for a decade or more with our screens. Um, but what we discovered that people were starting to come to us with was the particularly niche projects, the grand spectaculars, where they needed something that had never been done before, something in an odd shape, in an odd location. Um, we had the band. I wonder if I'm allowed to name drop here. Muse. Are you familiar with Muse?
Yes, very familiar.
We were approached by their tech team to ask if we could make an LED piano for them,
Oh,
and
wow.
they were insistent that the lid, the lovely curvy shape of
Mm.
this grand piano, should be covered in LED, but they wanted to cut the LED tiles to precisely follow the contours of the lid of the piano. That's unfortunately where the project stalled, because we haven't yet developed an LED tile that you can trim like
Mm.
origami. But yeah, it's projects like that that kept coming our way. And while we didn't do an LED piano for Muse, we certainly did one for Prince. And he toured Australia with an LED piano that I hand built when they chucked me on a plane and said, "Go to Australia with a bunch of LED tiles and make it work."
Wow. So I would imagine projects like that, are fairly large scale. Not only do you have to worry about the technical aspects of making the screen or piano work in the way that it has to, but also you have to think about moving it, the logistics of that. Talk to me about, I guess, the challenges that you guys face and how your team, I guess, overcomes them to complete these very, um, complicated projects.
Absolutely, absolutely. Well, I mean, whether an LED screen is the size of a grand piano or whether it's the size of a football pitch, um, believe me, that screen has to work. When push comes to shove, that screen needs to be lit. It needs to be showing bright, dazzling video, and heaven forbid it goes wrong during the event. It cannot fail. So we not only put a lot of design into how to make these screens portable, how to make them easy to rig and de-rig, but also how to make them robust. Um, I always say, if you want to field test a piece of kit, give it to some touring techs. Let them take it on the road. Let them rig it night after night after night and take it down at 4 a.m., put it on a truck, take it to the next venue, but do it all again the next day. There's nothing like field hardened technology that's survived rock and roll touring. But we discovered that the lessons learned, the expertise we had in the company with making touring equipment worked, could also be applied to permanent install products. Just because you're in a corporate boardroom somewhere screwing a screen to the wall doesn't mean that you don't want that process to be fast and slick and all of the equipment to go together well. So, yeah, lessons learnt in touring and rock and roll have very much been applied to permanent install products in the corporate world as well.
Yeah, it's you're testing it. One of the harshest environments in the world, you could say, with a rock and roll band. And
Absolutely, yes.
the touring team who has to quickly move them, from location to location. Banging around and being able to set it up quickly and having it function is of the utmost importance. Talk to me about that, because you've alluded to that as well in your permanent installation. Talk to me about how speed and design plays a factor for you guys, because I think that's important.
Absolutely. So, sadly, we live in a world where time is money. So, a project manager, a site manager, will somebody planning to put a screen on a site, they'll not only be looking at the capex of the screen, but the cost of the personnel needed to install the screen and commission the screen. It does come into play. Now, we've certainly seen that there's international variations. In the Americas, screen technicians are very expensive people to have. Other parts of the world, the prices can be variable, but if you're looking at the overall cost of a project, the speed and efficiency of the install team definitely comes into play. So if you have a product that clips together, locks together, anything to speed up the install, then that gets noted by the end client when they see that install and commissioning goes from 10 days to 4 days, and they love it. I'll give you an example. digiLED pioneered the use of magnets for holding the LED surface onto the chassis of a screen. Now, prior to magnets, back in the dim and distant days, there used to be screws, lots and lots of fiddly little screws. And these, you needed to be nimble with these. You needed the skill of a watchmaker to get all of these screws in the right place. As soon as magnetic mounting came along, you literally have to offer these tiles up, and the north and the south poles of the magnets grab each other, and the tile pops into place. And people say, hang on, is holding tiles on by magnets, is that safe? Is that secure? Well, I can confirm that for a corporate client in San Francisco, we undertook earthquake testing of a screen with a magnetic fascia to it. And we were actually complimented on how well the magnet technology holds up in a moving, vibrating, shaking structure.
Incredible. So it sounds like, you very well, perfectly articulated, something that we talk about on the show a lot. And ProtoCase we consider ourselves pioneers in mass custom manufacturing, and that's all about exactly what you talked about. It's about increasing the velocity of a project in order to reduce the latency and therefore reduce your cost for a number of reasons. Obviously, iteration cycles go down, and as you alluded, not only are technicians very expensive, so are engineers, it's very very interesting that you guys have identified that and brought that as a feature of your product to your customers. I'm wondering what you might do at dij-ee-led on the internal side of things to incorporate many of the same principles to reduce your cost when you're developing a product. How do you guys take in speed and velocity into account on your internal projects?
I like that word. Velocity is a very good way of expressing a project. In recent years, the capabilities of 3D modeling has just exploded. And here I am talking to you on a medium to high spec laptop that I do a lot of my 3D modeling on. It's been a steep learning curve for me, getting my head around step files and all the different projections. But once you've mastered it, the 3D environment becomes a fantastic place for creation and modeling and prototyping of environments, even to the point where I've sat in client meetings and sketched up some of the concepts for a screen. So I guess in my parents' generation, that would have been drawing board and parallel motions and pencils and pens. But here we are with a portable laptop where I can just fire up my 3D package and sketch something in no time at all. And I have to admit, ProtoCase Designer played perfectly into that. When I discovered that you'd got that software, I was like, wow, look at this, happy days. And I love the exploded view. Brilliant little thing.
Yeah, and that's that's something, a product that we're really proud of, because it demonstrates what we call HVMC, high velocity mass customization, really well. It allows you to kind of take that design concept and very quickly at high velocity turn it into reality, with the hopes of doing exactly what you're what you're describing and speeding up the project time and reducing costs. So I'm happy to hear that it's something that's been able to help you.
Very much so, yes.
I'm curious as well. I have in my notes about dij-ee-led that you guys have some innovations on the green technology side as well. Are you able to expand on what it is that you guys have done there and why it's important?
Yes, this is the Zeus story. So Zeus, zero energy use system.
I
So
love that.
Zeus was an innovation that came out of lockdown. It came out of COVID. And what sowed the seeds for Zeus was we've got a venue in London called the O2. I think it's London's largest indoor music venue. It's one of the world's most successful music venues. And the head of technical there approached me after lockdown and says, "Tom, what's going on? We've been closed for 18 months, 2 years, and yet my electricity bill is still sky high. What's going on?" And I've got a history with the O2. I helped set it up back in 2007, just before joining Digi. So I explained to the team there that while their LED screens were pseudo off, they were actually still fully operational and doing nothing more than playing black video. Now, what I've just described there, it's a dirty secret for our industry that has gone on for years. I can't tell you the number of times I've said to clients, just play black. It's effectively standby. Well, newsflash, it's not standby. We started doing measurements and we discovered that an LED screen playing black, the worst one we ever measured was burning 17% of its maximum power just to play black.
Wow.
And yet the industry has called this standby. And you'd think, I mean, these screens, they can burn kilowatts and kilowatts of power. It's not uncommon to run these on 125 amp three-phase supply. So 17% of that is substantial. Multiply that by a number of days per year or nights per year when the screen's playing black, and the cumulative kilowatt hours that a screen is wasting for no real reason is substantial. So that begs the question, why don't people turn screens off? It's a pretty obvious thing to do. And the answer to that is screens are actually really tricky to turn on. There's anyone in the industry will tell you that switching them off, no problem. Getting them on the next day, bit of a problem, because they're large industrial devices that consume serious amounts of power. But when they're off, when they're cold, there is an inrush as the capacitors and the power supplies are first energized. And this inrush, depending on that moment where you flick your breaker, that could be thousands of times the regular operating current of the device. So I bet you speak to any LED tech in the world and they will have experienced trying to energize breakers, and the first time you do it, it overloads. Maybe the second time you're successful, maybe the third time you do it, but you have to go click, click, click. And that's all these empty capacitors in this screen, desperate for energy when you first turn the thing on. So what I'm getting at here is a rather long-winded way of saying I came up with this invention that enables people to easily switch screens off, but most importantly, and this is where we've got an international patent, manages the power up process to ensure that the screen has a soft start and the electrical distribution network doesn't experience any horrendous inrushes.
Incredible, very interesting. It's amazing the innovations across speed, and now I would consider that's also a speed innovation, but also impacts the overall bill that people have to foot for energy and the impact on the environment. But I love how you guys have walked through what the challenges are, root cause them, and then came up with a very specific solution to fix those. the magnets and the startup system. As you were walking through that, it was just so interesting. I was waiting for you to tell me where you guys found the problem and how you've solved it so pointedly. I think that it's an incredible testament to your team's innovation.
Yeah, and Zeus really is the gift that keeps on giving. What we realised pretty quickly was if you've got a venue with a screen and your normal state of affairs, you need to run air conditioning to keep the venue cool, then Zeus has a double win.
Yeah.
For every kilowatt hour of energy that screen doesn't burn, that's X amount of BTU of air conditioning that is not required. And to give you some numbers, there's a screen we commissioned a month or so ago just on the entrance of the O2. It's 109 square meters, thereabouts. This screen switches off with Zeus every night at 11 p.m. The following day, it switches on again around 8 a.m. And I did the maths on how much power that's saving. One night of Zeus on that screen saves enough power to charge a Tesla for 300 kilometers of journey.
Wow.
So just one night on the screen. And again, a little bit of extrapolation, you stretch that over a year, and the power savings on that screen from Zeus give that Tesla enough distance to travel almost halfway to the moon.
Incredible.
Yeah.
Incredible. I wonder now that, again, you guys have made such leaps over your history, both in speed and in energy efficiency. What do you think is the next frontier for you and your team? What's the next big nail to hit in terms of innovation?
Oh, there's this is so unfortunate that I have just signed the most onerous NDA document for the most incredible project in the world, but I could tell you, but I'd have to kill you. So
That's okay, Tom.
What I can tell you is
that
the industry is definitely trending towards brighter screens, higher resolution screens, and tighter pixel pitch screens. All through my career in LED, the distance between neighbouring pixels has been getting closer and closer. But when I started, you could have 30 millimeters from pixel to pixel. Around millennium time, my first ever television job, I remember being awestruck by this screen that had a 6 millimeter pixel pitch. So much so, I've still got a photo of me holding up a coin next to these pixels just so I can show my friends, look how close he's got, 6 millimeters. Fast forward to today, and sub 1 millimeter is available. It's practical. It's a commercially viable product. I mean, these are resolutions and pixel pitches that absolutely match projector pixel densities. Wow. And even LCDs. A large commercial LCD screen will have pixels just under 1 millimeter between them. So, yeah, there's LED is, like all electronics, the density that you can fit within a given area is just growing and growing and growing. And the battle is to keep that very dense electronics running cool and running efficiently. So efficiency and brightness go absolutely hand in hand with screens. Side note, if you're ever looking around at screens and you see a screen at a concert or maybe in town somewhere, and that screen has a blue tinge to it, did you know that that's an overheating screen?
Oh, I did not know that.
Despite the blue colour, the red LED is the first LED to fade when it gets hot. And with the absence of the red, your image becomes very blue tinged. So have a look around. Next time you see a blue tinged screen, that screen is crying out for help.
Absolutely. And in the meantime, we'll have to have you back on once the NDA is opened. Yes. Opened up. I'd love to discuss it again. However, if anybody's wondering in the meantime, I guess, how to find out more about digi-LED or digi-LED and maybe work with you on a project, where would they find you guys?
Well, the clue's in the name, digiled.com, digiled.com. And the website there is full of the projects that we can talk about. And there's a few spectaculars on there. So do pop along and have a look at the website.
Amazing. Thank you so much for coming on, Tom. Super insightful, incredible to learn about your innovation, and I definitely have to have you back on in the hopefully near future.
That's great. Thank you very much, Jordan.
Okay. Bye-bye.
Bye-bye.